write a question. If f of t is equal to t square sin omega t, t square sin omega t, find its Laplace transform. Find its Laplace transform. Okay, how can we do this? What equation you can use for solving such type of question in Laplace transform? F of t is equal to t square into sin omega t. How can we start with? See, here f of t is nothing but f of t is equal to t square into sin of omega t, right? This is in the form of f of t will be equal to t raised to n into f of t, right? This is the form of f of t is equal to t raised to n into f of t. That means we have to find the Laplace transform of what is that? T raised to n into f of t, right? Which is nothing but beta, which is nothing but what is that? Minus 1 the whole raised to n into d raised to n divided by ds raised to n into what is that? F of s, correct? D raised to n into ds raised to n into f of s. Is it correct? Correct. So this is the equation we have to use here. This is the equation we have to use here, and see how it can be applied. See how it can be applied. Here f of t is nothing but in the given question it is nothing but what? This sin omega t, right? Sin of omega t. Our f of t, right? Our f of t, not in the question f of t, it is capital F, but small f of t is nothing. Okay, our f of t is nothing but sin omega t, and n is nothing but 2, right? T raised to n, right? 2 raised. So definitely L of capital F of t will be equal to what, beta? Minus 1 the whole raised to n, that is nothing but 2 into d square by ds square of f of s. What is f of s here? What is the Laplace transform of sin omega t? Which is nothing but beta omega divided by s square plus omega square. Correct or wrong? Is it correct? Is it correct, beta? So we have to double differentiate this thing, right? So minus 1 the whole square is nothing but 1 itself, no doubt in that. That is nothing but d by ds of what is that? Omega divided by s square plus omega. Am I correct? Am I correct, beta? Which is nothing but d by ds of what is d by ds of s square plus omega square. See, how can we do this? How can we do this? You can directly go for quotient rule, okay? No need, you can solve in any manner. I will prefer that. So denominator into d by dt of numerator, that is nothing but 0, minus numerator into d by dt of denominator, which is nothing but 2s, right? Whole divided by denominator square. Correct? So this will be d by ds of this will be goes to 0 and minus omega 2 omega s whole divided by s square plus omega square the whole square, right? S square plus omega square the whole square. Correct? Again you have to differentiate once more. There is nothing but again denominator into minus you can take outside. So which is equal to minus of denominator is nothing but s square plus omega square the whole square, right? Denominator into d by dt of numerator is nothing but minus 2 omega, right? Minus 2 omega, correct? D by ds of minus 2 omega is nothing but minus 2 omega, correct? Minus numerator into numerator is nothing but what? 2 omega s, right? 2 omega s into d by ds of denominator, which is nothing but what? 2 into s square plus omega square raised to 2 minus 1 is nothing but 1 into what is that? 2s. Whole divided by what, beta? Denominator square again. So s square plus omega square the whole raised to 4, correct? Whole raised to 4, which is nothing but minus minus of, again this minus can be taken outside, so the whole minus can be taken out, so it will be plus cancelled, so no issues there. So it will be nothing but s square plus omega square the whole square into 2 omega minus 2 omega s into, again 2 is there now, so it will be 4 omega s into, again 2s now, it will be 8 omega s square, right, into s square plus omega square, correct, whole divided by s square plus omega square the whole raised to 4. Now in examination this much of what not cancelling terms will not be there, possibly there will be some cancelling terms in the question. This is just an example, no? Arbitrarily I chosen this as an example, so this is the way in which you have to solve the problem. The main aim is, my aim is, you have to know the how we can start with, how can we solve the problem, right? So that's all about the question. Okay, you can simplify directly, simplify from maximum value, you can cross multiply it and you can expand this, no issue, you can do this. Okay, this is the way you have to solve. Is it clear to you? Is it clear to you better? And our important area is nothing but inverse Laplace transform. Okay, inverse Laplace transform. So write a question. Find the inverse Laplace transform of inverse transform 1 by s plus 4. Very important. Very important. Find the inverse Laplace transform of 1 by s plus 3 into s plus 4. How can we solve? How can we start with? You already know, you already studied in beta classes. It is nothing but partial fraction method. This can be solved by using partial fraction method because it is in the form of y 1 divided by s plus something into s plus something, no? It is no conjoined, right? So you have to fractionize it by using partial fraction method. Okay. So what we do for that method? It is nothing but, listen carefully. 1 by s into, but 1 by s plus 3 into s plus 4 can be write it as, using partial fraction, it can be write it as a divided by s plus 3, a divided by s plus 3 plus b divided by s plus 4. This is the way in which you can split this single equation to simple complex two equations, right? So we have to find the value of a and b. There is a trick for finding a and b. For finding the value of a beta, for finding the value of a, in the original equation, a is nothing but for corresponding to this and b is nothing for corresponding to this, right? So for finding a, cover this equation like this, means the terms containing a you can cover this, and you can substitute s is equal to minus 3. That minus 3, where it came from, that minus 3? Because s plus 3 equal to 0 will give s is equal to minus 3, right? So cover this a containing term and put the remaining term as s is equal to minus 3. Then you will get the value of a. Okay, let us do that. I am using duster for that. So I covered this term and I have to put the remaining term by s is equal to minus 3. So s is equal to minus 3 and plus 4. So it will become 1 by 1, which is nothing but 1. So you got the value of a as 1. Similarly, for finding b beta, for finding b, it's very easy. For finding b also, you have to cover the term containing this b and put what value of s for getting b. Put s is equal to minus 4. Where that minus 4 came from? S plus 4 equal to 0, s is equal to minus 4. So cover this b term and the remaining term you put s is equal to what? Minus 4. So it will become 1 divided by minus 4 plus 3, which is nothing but beta minus 1, which is minus 1. So now you got the value of a equal to 1 and b equal to minus 1. So our equation will become our equation will become f of s is equal to, what is that? F of s is equal to, this Laplace transform will be definitely f of s, f of s, right? Capital F of s will be equal to a by s plus 3, that is nothing but 1 divided by s plus 3 plus b, that is minus 1 divided by s plus 4, correct? Minus 1 divided by s plus 4. Am I correct or no? Correct. So f of t is nothing but L inverse f of s, correct? L inverse f of s, right? So it will become, what is the inverse of 1 by s plus 3? What was the Laplace transform of 1 by s plus 3? E raised to minus 3t, correct? So the inverse of this will be nothing but e raised to minus 3t, minus 1 is there now, so minus, what was the Laplace transform of 1 by s plus 4? It is nothing but e raised to minus 4t. Because what is the Laplace transform of e raised to minus 3t? You studied in the table now. You studied in the table, right? It is 1 by s plus 3. What was the Laplace transform of e raised to minus 4t? It is 1 divided by s plus 4. You generally derive the equation, right? E raised to at and e raised to minus at for that, right? So it will be like this. So this is the answer. So this is the inverse Laplace transform. Is it clear better? Is there any doubt? Is there any doubt? Small doubt you can ask. If there any small doubt you can ask, okay? And write another question, okay? Write another question. Find the inverse Laplace of f of s is equal to 2 divided by s minus a the whole square, sorry, whole cube. How can we find the inverse Laplace form of 2 divided by s minus a the whole cube? So you have to think two things in your mind. You have to think about two things in your mind, or two equations in your mind, which is nothing but what is the Laplace transform of 2 by t cube? What is the Laplace, inverse Laplace, if it is 2 by t cube, what will be its time domain? If the answer is 2 by t cube, that is Laplace transform is 2 by t cube, then what will be its answer? Its question. You have to reverse think. What will be the question? And what will be the question if it's something divided by s minus a? From where it originated? Two things you have to think about. And the answer will lie in that thinking. Okay? That is nothing but f of t will be equal to beta. It is nothing but t square into e raised to at. T square into e raised to at. If you take the Laplace of this, you will get this. Okay? That means if it is in the form of t raised to n into f of t, t raised to n into f of t, right? T raised to n into f of t. In that way only you can think. Easy way is nothing but 1 divided by s minus a. 1 divided by s minus a. What is that? E raised to at, correct? So e raised to at, 2 divided by s minus a the whole cube. So the Laplace transform of t square is nothing but beta n factorial divided by s raised to n plus 1, correct? Which is nothing but 2 factorial divided by s raised to n plus, which is nothing but 2 plus 1. 2 divided by s cube. So t square is in the form of 2 by s cube Laplace transform. So 2 by s minus a will be simply nothing but e raised to at into t square. T square into e raised to at. This is you have to think by yourself. Okay, this idea should be in your mind. So by doing so many problems only this can be arrived. Okay, if I do so many problems regarding Laplace transform, then what is the use in electrical will not get enough time. So I am going to do what we can do with this Laplace in our electrical engineering. Okay, and I am not going to do the full concept of Laplace transform in mathematics session. No, it will be pure mathematics. No, it will be pure mathematics. So you can refer your old textbook. Okay, old textbook you can refer, mathematics textbook you can refer, and you can solve whenever you get time. You can revise those things. That will be a benefit. Otherwise, it will be more time consuming, right? So this is the answer. So this is the answer. Okay. And in electrical, what we can do, that we will do. Okay. Okay. Listen. Inductor circuit. First one, inductor circuit. Inductor circuit. Listen carefully, beta. So what will be the equation for voltage equation here? What will be the voltage equation here? VL of t is nothing but beta L into d by dt of IL of t. Am I correct? L into d by dt of IL of t, correct? So taking the Laplace transform of both sides, this equation both sides, what I get? VL of S will be equal to L into what is d by dt of IL of t? Laplace transform of d by dt of IL of t. I can write like S into IL of S minus IL of 0. 0 minus. Correct? Am I correct, beta? S into IL of S minus IL of 0. Okay. So again multiply these, it will be LS into IL of S minus L into IL of 0 minus, which is nothing but VL of S. So I am going to convert the same figure in the time domain to S domain figure, the time domain figure to S domain figure, Laplace transform figure. Okay, what I get? This is our reference equation. So what I get? See, so this will be my VL of S, right? This will be my VL of S, right? So VL of S is equal to, I can write like IL of S be the current here. So IL of S be the current here. And this IL of S is flowing now, this IL of S is flowing, right? So it will become, okay, let be like this, LS into IL of S minus, so I can change my circuit like a voltage source of L into IL of 0 minus, L into IL of 0, correct? So this will be the representation of this one. This will be the S domain representation of this one. Listen very carefully. I did nothing. I simply write the voltage equation here. VL of t is equal to L into d by dt. Take Laplace transform on both sides. So this will be the Laplace transform. Simple, you know the d by dt of Laplace transform, like d by dt of f of t Laplace transform is f of S minus S into f of S minus f of 0. That f of 0 is small f of 0, right? So small IL of 0. Okay. So apply this equation, I get what? Convert it into simple Laplace transform S domain figure. VL of S will be equal to, right? VL of S, same voltage equation you can apply here. The current is nothing but IL of S now, so it will be IL of S. So VL of S minus or equal to IL of S into LS, right? IL of S into LS. So the inductor can be, when you convert the inductor in the time domain to the inductor in the S domain, its value will be L into S. If you multiply this inductance L with the L into S, it will become XL, because S is nothing but beta j omega. So L into j omega is nothing but XL, simple. So if you directly, if you simply multiply it with S, means you no need to separately calculate for XS, because that itself gives the value of XS. That itself gives the value of XL. So no need to convert to multiply with omega and all, you no need that, because if you multiply this L with S, means at that time that converted into inductive reactance, not inductance. Okay, so LS, and there is a voltage source of minus L into IL of 0 minus. There is a voltage source of minus L into IL of 0, because we studied already, because in inductor at a t greater than 0, at any condition at t greater than 0, there is a chance of IL of 0 all the time, right? Sometime it may be 0, sometime it may be 0, IL of 0 is equal to 0 in some calculation and all, in some problems and all we did and we saw that in some cases IL of 0 will be definitely 0, but most of the cases is not like that. Most of the cases some IL of 0 will be there. So that IL of 0 should be included in the circuit diagram, right, for t greater than 0 now. So this is the diagram for t greater than 0 and this is the diagram for s greater than 0. Simple. Because Laplace is only applicable for s is equal to 0 to infinity. You may have a doubt that why I didn't write the Laplace equation for t less than 0 condition, because t less than 0, no, there is no existence of Laplace, because the definition of Laplace itself gave f of s is nothing but 0 to infinity, f of t into e raised to minus t, s dt, sorry ds, right? So that means if you have dt, right, dt, if you have to convert something into Laplace, means it contains the term from 0 to infinity only. That is why at t greater than 0 I did for Laplace, not for t less than 0. I don't need to convert that into Laplace when t less than 0. Only when t greater than 0, this is the condition for t greater than 0, this is the condition also for t greater than similar, t greater than 0 or s greater than 0, simple. Clear? So whenever you convert an inductor into Laplace transform, you have to multiply, L will be converted into Ls and the initial voltage will be L into IL of 0 minus, L into IL of 0 minus, bus. That is the concept of inductor circuit. Let's talk about the capacitor circuit. What is it? Let's go for a capacitor circuit. What it will be? So the voltage equation is nothing but beta correct? IC of t will be equal to C into d by dt Vc of t, though you can have the equation for a capacitor, you know this, right? If you have to convert it into taking Laplace on both sides, it will become IC of s will be equal to C into what is d by dt Vc of t beta? It will be s into Vc of s, right? S into Vc of s minus Vc of 0 minus, correct or wrong? Correct or wrong? That means IC of s will be equal to Cs into Vc of s minus C into Vc of 0 minus, correct? C into Vc of 0, correct? So from this, what is Vc of s here? Okay, IC of plus C into Vc of 0 minus divided by Cs will be equal to Vc of s beta, correct? Correct beta? So that will be nothing but IC of s by Cs plus Vc of 0 minus by s, correct na, equal to Vc of s. So now you have another equation, voltage equation, like this equation. That's why to this format I have to convert. That's why it took some time in order to get that. So this is our voltage equation in capacitor circuit. This is our voltage equation in capacitor circuit. That means this Vc of s can be write like, I can draw this equivalent time domain figure to s domain figure as, listen very carefully, better listen very carefully. Listen very carefully. Correct. See the figure. So this is the S domain representation of the same figure. See, this equation satisfy this or no? Correct? Can you see that? See, Vc of S is equal to, that is Vc of S, apply KVL here, Vc of S minus Ic of S into 1 by Cs. Same manner, if you convert this L into Ls, it will be automatically what? Inductive reactance. Similarly, if you multiply C with 1 by Cs, in Laplace transform, that C will become 1 by Cs. 1 by Cs is nothing but beta. It is equivalent to XC. You can check that. It is equal to XC. It is equal to XC. Because XC is equal to nothing but 1 by C omega. X equal to 1 by C omega. 1 by C into omega is nothing but J into 2 pi F. Nothing but S is equal to J omega, right? That's the equation. So if you multiply that C, if you convert it into Laplace transform, what I get? It is 1 by Cs. It is 1 by Cs. If you have 1 by Cs means it is simply capacitive reactance. So what is the Kvl equation here? Vc of S minus Ic of S into 1 by Cs. Directly you can multiply, right? So Ic of S into 1 by Cs now. Ic of S into 1 by Cs minus Vc of 0 by S, right? So minus Vc of 0. This will be converted to that type, no? This is Vc of S minus, if it will be Vc of S by S. That means the Laplace transform of the constant, I mean Vc of S by Vc of 0 minus divided by S means what? The Laplace transform of Vc of 0 is in the time domain will be converted into the Vc of 0 by S in the S domain. Clear? The Laplace transform of IL of 0 IL of 0 in the time domain will be converted like L into IL of 0 minus in the what? S domain. Bus. Is it clear? Is it clear? I mean, this also contains some initial charges. This also contains some initial charges or initial voltage. That is why. Okay. You have to just remember two things. One, whenever you have to convert inductor in the time domain to its Laplace transform in S domain, it becomes L into S. Whenever you have to whenever you see a capacitor in time domain, if you have to convert that into frequency domain, I mean S domain, it will be simply what? 1 by Cs bus. This is the only thing you have to check. And this is for analyzing, I mean this is for understanding how it obtained. If I directly wrote 1 by Cs will be, if I directly wrote 1 by, I mean Ls will be, then you will be in confusion, right? Okay, how can we obtain it? In the electrical session, I mean from electrical engineering itself, teacher is also saying the same thing. Whenever you have to convert from, I mean time domain to this S domain, it will be Ls 1 by Cs. Oh, these are also taking the same manner. You may think right. You may think right. That is why I derived all this, for the understanding purpose. Okay. So just we need these two things. Okay. So let's do a question so that we can apply our what Laplace transform there. Then how beautifully we can arrive the answer. Let's see that. Let's see that. Okay. So please note it. Please note it better. Please note it. Okay, let's do a question now. Let's do a question now. Find Ic of t. Find IC of t beta. This is our question. You can use any method, no? You can use our conventional method, no? That also you can use, but you can use Laplace also. That I will discuss now. How can we solve this question for Laplace? By using Laplace transform. Okay. Draw this figure. Draw this figure. Okay. Okay. So can we start? Can we start better? So our analysis start normally from t equal to 0 minus. What was the purpose of doing t is equal to 0 minus in all transients problem? See, whenever there is a switch and some two type circuit, no, whenever there is a switch there, definitely that is related to transient analysis, no. So you can directly blindly you can start from t is equal to 0 minus and you can continue. Okay, most of the problem contain this type of switch and t equal to 0. Whenever you see t equal to 0, switch is changing, definitely that is connected to transient analysis. Then you can easily start from that. No need to think and all. Okay. So t is equal to 0 minus means what will be the circuit position? At t equal to 0 only the switch is connected to this port, right? The switch is connected to this section. Otherwise, simply at t less than 0 means, or t is equal to 0 minus means, this will be the circuit. This circuit will not be there, right? So this will be the circuit. So that, listen carefully, it will be 20 volt, and this is nothing but 10 volt, right? 10 ohm, correct? And the capacitor will be what beta? Capacitor will be at t is equal to 0 minus is a steady state condition now. So the capacitor will act as an open circuit, right? So this session will be the VC12, okay, C12, 12 farad means VC12 of 0 minus. So this will be the value. So this is the initial voltage across the capacitor. So what will be the voltage? VC12 of 0 minus will be nothing but beta 20 volt, right? 20 volt. Because there is no current flowing in the circuit because it is open circuit now. So all of the voltage will be allowed here. So that will be 20 volt. And at a t is equal to 0 minus, there are two capacitors, right? One is 12 farad and another one is 6 farad. So initial condition of voltages now, for those two capacitors also we have to find, right? At a t less than 0, we find the initial voltage of 12 farad, right? That is nothing but 20 volt. But what about that 6 farad? The 6 farad is not in the circuit for t less than 0. This is not in the circuit. This is excluded from the circuit, right? So simply you can write VC6 of, right, 0 minus is nothing but beta 0 volt. You can directly write that. So that is the condition for t equal to 0 minus condition. Then what will be at t greater than 0? At t greater than 0, what would be the circuit? At t greater than 0, listen very carefully. The switch is connected to this side. It will be a source free circuit then. This will be excluded from the circuit because at t is equal to 0, it is switched from here to here. That is the meaning of this arrow. It is switched from here to here. That is the meaning of this arrow. Clear beta? So this will be the circuit now. This will be the circuit. This will not be there. So our diagram will become, listen very carefully. It having certain voltage, right? Initial voltage. What is the initial voltage? We set 20 volt now. 12 farad, right? It having initial voltage 0, so no not right. So it is 6 farad, right? It's 2 ohm, right? IC/t. Correct? So now I am going to convert this figure into Laplace transform. See how beautifully you can arrive answers, how easily you can arrive answers. Convert this into Laplace transform. Convert this into Laplace transform. It will become, what is the Laplace transform? Constant beta. What is the Laplace transform of a constant value? k value or k or a. What is the Laplace transform of a? It is a by s now. So what is the 20? This 20 volt, no, this 20 volt is a constant DC supply, right? So what is the Laplace value? It will be simply 20 by s, right? 20 by s. What will be the Laplace transform of 12 farad? It is in farad. It will be 1 by 12s, correct? And what will be the Laplace transform of 2 ohm? There is no Laplace transform, it is 2 ohm, right? Simply 2, no need to confuse. Laplace transform 2, no, it is simply 2, right? It is not a constant, it is a resistor actually. Laplace transform of a constant is, we can say that is 1 by s, but we can't say that 2 by s here because it is not a constant, it is a resistor. It is a property of an element, right? Resistance is a property of an element, it is not a constant. But voltage source means it having a constant magnitude now. That is why you have to distinguish the difference, right? The Laplace transform is not applicable for that resistance because that resistance is frequency independent term, right? Frequency independent term, that is 2 ohm is the property of the material. So that is independent of frequency. Resistor case. Laplace is applicable, or in other words, the transition condition will only affect the inductor and capacitor, or not for resistor, right? That way also you can think. And what will be the Laplace of this one? 1 by 6s bus. And what will be the current beta? IC of s, right? IC of s. What will be the current value? IC of s. What will be the current value? IC of s. Okay. So can you write the Kvl equation here? Can you write that? 20 by s is equal to, or 20 by s minus 1 by 12s into I of s or IC of s minus 1 by 6s into IC of s minus 2 into IC of s equal to what? Beta 0, right? Simply apply the Kvl here. Simply apply Kvl in this loop. 20 by s minus 1 by 12 is into IC of s minus, like that, okay? Which is nothing but beta 20 by s equal to IC of s into, beta listen very carefully, IC of s into 1 by 12s plus 1 by 6s plus 2. But it is from this IC of s is nothing but beta, IC of s is nothing but 20 by s whole divided by 1 by 12s plus 1 by 6s plus 2. Correct or wrong? Correct. Which is nothing but 20 by s whole divided by, can multiply with 12s, what I get? Take 12s outside or multiply with 12s. So here also by 12s. You can multiply with 12s on both numerator and denominator. You can take numerator and denominator 12s. Or LCM as 12s, no? LCM as 12s. 1 plus 2 plus 24s. Correct? It will become 20 by s all divided by 24s plus 3, right? Divided by 12s. So it will become, I can do it here. Correct, beta? Correct. So I can what will be that? IC of s is equal to s and get cancelled now. 12 into 20 will be 240, right? Divided by 24, you can take an outside again. 24 into s plus 3 by 24, you can take. Correct, beta. This can be cut and it will be 10, right? So it will become finally IC of S will be equal to 10 divided by S plus 3 by 24. See how easy it will be now. IC of T will be simply nothing but L inverse IC of S, which is nothing but 10 e raised to minus 3 by 24. This is the answer. 10 e raised to 3 by 24 t. Your aim is to find IC of S first, because we have to find IC of T. So IC of S you have to calculate first. That's why we convert this equation into Laplace transform. And second thing, what remains at t is equal to 0 minus condition, you no need to go for Laplace transform, because at t is equal to 0 minus condition is there is no Laplace existing. Laplace is defined only for t greater than 0. That means the definition of the Laplace itself gives an idea of what it exists for 0 to infinity only. So t is less than 0 condition is not exist Laplace, not exist in case of Laplace. So you have to consider for only t greater than 0. So first of all we have to draw the figure for t greater than 0, convert those parameters into constant, and remain. I will remind you one thing. No need to convert the resistor into Laplace transform, it's simply resistor itself. But voltage source you have to consider, because it also varying, no? It also varying sometime. So it will be 20, I mean constant by S will be the what? Laplace transform of constant, and there will not be any change in the resistance even in the Laplace or even in the time domain, there is no change. And then you have to find the IC of S. You found out IC of S. The thing is that you have to make the equation in the form of A by S plus something or A by S minus something, so that you can take whatever it is along with this S, no, that you can take outside and make S free. Coefficient of S, you have to make coefficient of S always 1. Then only we can easily take the inverse Laplace transform. That is the main thing. If it is there as 24s, then it will be very difficult to find its inverse transform. Simply you can take that 24s outside. It will be that S will be free. S plus or minus, we don't bother about. You will have an equation of inverse transform as e raised to plus or minus at, no issues there. So that is the aim of doing this 24 to be taken as outside. Remain is simple mathematics. Remain thing is simple mathematics. Is it clear? But is it clear to you? So that's all about the answer. Okay. Please note it. Please note it. Okay. So let's go for another question. Let's go for another question. See, the thing is understanding. The important thing is nothing but understanding a problem. Write a question later. So the question is, find I of t. Find I of t. Simply IL of t, you know, IL of t. IL of t, because in through inductor that current is flowing, right? So IL of t also you can represent. How can we start with? How can we start with such a question? How can we start with such a question? Again, our same methodology. It is nothing but beta. What is that? At t equal to 0 minus condition. In order to get the initial values of current in the inductor, right? That is the main purpose of doing that. So at t is equal to 0 minus means the switch was in open position, right? At t is equal to 0 minus means less than 0 means the switch was in open position. So at t equal to 0 only it is closed, right? So at t is equal to 0 minus means this was in open position. So these will be there in the circuit, right? So our circuit diagram will become Inductor will be what? Short circuit. IL of 0 minus. And this will be 3 ohm and this will be 2 ohm. So what is the value of IL of 0 here? So IL of 0 minus is nothing but beta 4 ampere. Correct or wrong beta? Correct or wrong? Correct. Then you have to go for at t greater than 0, right? Same procedure is there, but the concept should be you have to carefully observe the circuit. That is the main thing. At t greater than 0 beta, that switch is closed, right? The switch is closed means this portion is short circuit, right? So these are also short circuit. That means the 3 ohm will not be there in the circuit for t greater than 0. So let's do that. Let's do that. This 20 ohm is 20 there, 20 volt is there, no doubt. 3 ohm will not be, but this 2 ohm will be there, right? 2 ohm will be there. And the inductor is represented with what? An inductor in parallel with what? T greater than 0 means inductor will be there, na? Correct? 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 So that is the time number representation for t greater than 0. Next thing is, normally in time itself you have to calculate this for t greater than 0. You can consider for t equal to infinity condition. That will give the value of or IL of t. For time domain, how can we solve this? IL of t will be equal to IL of 0 minus IL of infinity e raised to minus t by RL e minus t by tau plus IL of infinity. In that way you can solve. But we are going to do this in transform, Laplace also. So convert this into Laplace also. Convert this into Laplace. How can we convert this? Listen very carefully. 20 volt will become beta. It will become 20 volt will become 20 by S, correct? 2 ohm will be as like 2 ohm, no change in that. And inductor in the time domain will be converted into what is the value? Inductor in the time domain will be converted into Laplace transform as the same inductor with a voltage source like this. And the voltage source value will be what? L into IL of 0 minus. Did you remember that? And L is nothing but beta 1 Henry. So 1 into IL of 0 minus. IL of 0 minus is nothing but 4 ampere. So this will be 4 volt. It's a voltage source, right? Did you remember the figure in inductor? So this will be the figure. Minus plus like this. In case of capacitor it will be upper plus and lower minus. But in the case of inductor it will be minus and plus. Did you remember that? I will tell you again, okay? And this 1 into Henry, 1 Henry inductor will be converted into what? LS, right? Which is nothing but 1 into S simply S. That also in ohm, right? S is that also in ohm. XL is in ohm, right? So that also in ohm. Now you can apply KVL here. That is 20 by S minus, this current is nothing but beta IL of S, correct? IL of S. IL of S. Correct? So 20 by S minus 2 into IL of S minus LS into IL of S, correct? Minus plus 4, right? KVL. Apply KVL in this loop plus 20 by S minus 2 into IL of S minus IL and IL of S. Again increasing potential. Here also increasing potential, right? Here also minus to plus means increasing potential. Here also minus to plus to increasing potential. That is why plus 4 equal to 0. Or I can write like 20 by S equal to IL of S into 2 plus LS. LS is nothing but beta S is simply S. S plus 4, correct? Or I can write like 20 by S minus 4 will be equal to IL of S into 2 plus S. Or I can write IL of S will be equal to 20 by S minus 4 whole divided by s plus 2. Correct beta? Correct that? Okay? Correct. Is it correct? Yes, made a small mistake there. It will be minus now. It will be minus, right? That side it will be minus, right? And here it will be plus, right? This will be plus, right? Correct. So 20 by s plus 4 divided by s plus 2, right? So that will be the equation for IL of s. Then simplify again. I will do that. 20 by s divided by s plus 2 plus 4 divided by s plus 2. See, this section is in the term of for a divided by or something divided by s plus something. So that can be easily take inverse Laplace transform. But see, this is something complicated now. So we can convert this also into simplified form. So this will become what will be that? IL of s will be equal to this 20 by s, right beta? 20 by s, right, divided by, you can take it will be, okay, $20 by s into s plus 2, correct or wrong beta? Correct. Plus 4 divided by s plus 2. Correct? So you have to convert this into first partial fraction, so that it will become, take this into partial fraction, like what will be that? Will become a by s divided by b by s plus 2, correct? What is the value of a here? In order to get the value of a, mark this section. In order to get the value of a, remove this section, cover this section containing s is equal to a, this is, and remaining term you have to put s is equal to 0. So it will be 20 by 2 will be equal to a. So a will be equal to 10. And for b, what you have to do for b? Cover the section which contain b, which is nothing but this term, right? Cover this section, contain b, and put s is equal to minus 2 in remaining section, that is 20 divided by minus 2. 20 divided by minus 2 beta. It is nothing but minus 10. B is equal to minus 10. Did you get that? Okay. Did you get that? Okay, anyway you can convert, no issues there. And see, so this section will become simply IL of s will be equal to what beta? 10 divided by s plus minus, right? B is minus now. Minus 10 divided by s plus 2 plus 4 divided by s plus 2. It will become IL of t is nothing but taking inverse of this, right? So it will become, what is the inverse? 10 by s means in time term it will be simply 10, right? Then only it will be 10 by s, right? In inverse time. So in time term it will be simply 10 minus 10 into e raised to minus 2t plus 4 into e raised to minus 2t. Correct. So it will become, listen carefully beta, 10 minus 6 e raised to minus 2t. So that is the answer. 10 minus 6 e raised to minus 2t. Bas, kadam khali. That is the answer. That is the final answer. See, how can we solve? It is somewhat easy, right? In time domain, for complete time domain analysis also you can do the same problem, no issues there. You can do this. Consider this, at a t equal to infinity condition you can apply that. At t equal to infinity also what happened? T equal to infinity inductor will be short circuited, so that 4 will be also short circuited condition. You can find IL of infinity also. You can find it tau is equal to L by R, you can find from this L by R at t greater than 0 condition. You can find that in that way also, same answer will be obtained. Same answer will be obtained. But this is somewhat easy, no? This is somewhat easy. That's why. Clear, beta? Clear? Did you note this? Did you note this? Is there any doubt? You can ask. Is there any doubt? You can ask, beta. Is there any doubt? You can ask. Okay? So that's all for the today's session. So hope you all are revising your subject. Revising the subject regularly. Please do revision, because if there is no revision means it all in vain. Because revision is very, very important. Revision is very, very important. And these minute things from plus minus and minus and plus, these things can be only keep in your mind whenever you do problems, whenever you do revision. And doing revision, I will tell one more thing. Whenever you do revision, take a rough paper and you have to write down and revise. Someone may overconfident that, someone may, okay, this I know why. Simply read and simply go, right? Simply read and go. It's not the revision. If you revise very, especially this is a problematic session, right? If you revise this problematic session, what way you are choosing if you do or revision for your mathematics on mathematics 1 or mathematics 2? Suppose 2-3 days before examination, what did you do at that time? You simply revise by simply reading? No, you simply write now. You write and did the revision, right? Similarly, you write and do your revision, because it's problematic paper, right? So that's why. Okay, and equations also, no, if you write something, it will be 10 to 20 times what gripper than what you simply read. Okay, that's the power of writing. Okay, please do write and study, write and study. And one more thing regarding lecture notes, right? You can refer any of the notes, no issues there. But my way, and I am using my note as my reference. I definitely refer from somewhere else and I got my note, and my written notes na, that is the best note in my view I have. So for all this will be their lecture note na, their lecture note will be the best book for them. Don't go beyond for some other books and all. You write it in your own language. You write in your own language and study. That will be more powerful than other textbook or others book, others notebook. Okay, your book will be benefit for you at the time of examination more than others book. This is my word. Okay, so that's all for today's session. Let's meet again tomorrow. Okay, so bye.